Alright guys, so today we are going to be doing the Beanium lab, and what this lab is all about is trying to represent isotopes of different elements using beans. Alright, so right now I've got a sample here that I'm going to call Beanium. So this is an element called Beanium. Each individual bean represents one atom of this element called Beanium. And I see three different kinds of atoms here. I see this kind, I see this kind, and I see this kind. Alright? Now, these three kinds up here, 1, 2, and 3, are going to represent three different isotopes of the element called Beanium. Okay? Let's sort these out. I want to figure out how many of each isotope I have. I'm going to put these small ones called lentils over there. I'm going to sort my pinto beans in the middle here, and the large garbanzo beans will be sorted separately as well. Alright, so I have sorted all of my isotopes separately. What I want to do here, I want to figure out the weighted average atomic mass for Beanium. Okay, the weighted average atomic mass. In order to do that, I need to figure out first the percent abundance of each isotope. I need to figure out the average mass of each atom, and then I can figure out the weighted average atomic mass. Alright, so for percent abundance, if I wanted to figure out how, what percent of my total sample is garbanzo bean, which is to say, in a real life example, what percent of a certain sample of carbon is the carbon-14 isotope. I want to figure out what percentage is garbanzo. What I want to do is count each type of isotope. Okay? So I'll have a certain number of garbanzos, a certain number of pintos, and a certain number of lentils. If I were to total that number, alright, that gets me the total number. I want to divide a certain number by the total to get the percent. Now, the percent that I'm looking for is the percent of a certain isotope at that time. If I count 1, 2, 3, 4, 5 pinto beans, I could say, alright, 5 pinto beans divided by the total number of beans gets me the percent that is pinto. For example, if I had a bag of marbles that was there's 15 marbles in there. There were 5 purples, 5 greens, and 5 reds. I want to figure out what percent of that bag is purple. Well, I know there are 5 purple marbles. I know there are 15 marbles total, so 5 divided by 15 gets me a 33% abundance for purple marbles. Well, in this case, 5 pintos divided by the total number gets me the percent abundance. What this lab is going to be difficult, or how it's going to be difficult, is figuring out how to apply this percent abundance along with the average mass per bean and figuring out the weighted average atomic mass. We should be using our worksheets that we worked on earlier this week to figure out the equation for weighted average atomic mass given these different isotopes.